Okay, so we're talking about Grasshopper, okay? What are we doing? What are we doing learning Grasshopper? What is Grasshopper and why are we going to learn it? Whenever we start with a new program, we always have to ask ourselves, why am I learning this? We have to start with why. There's going to be so many programs that are going to come out over the time of your course of being an architect. And quite honestly, all the ones that we're using right now, there's no guarantee that these are the ones we're going to be using 20, 30 years from now. So if we're thinking long term, we have to imagine a life where new programs come out, new programs become the industry standard, and we have to learn them. So we're imagining being prepared to learn new programs as the times change and not necessarily rely on the ones that we've always known. So if we think about that, Grasshopper is one of the options that we might use. We might want to learn it. But if we're going to ask ourselves why Grasshopper, we have to know, what is Grasshopper designed for? Okay, so you're asking yourself, why would I learn that program? You say, what does this program supposed to do? What did the engineers of the program design it to give you the powers to do? Or maybe if you want to think of it another way, you could say, what are the possible outcomes that could be made using Grasshopper? Okay, and this starts to give you a clue of if it's worth learning your time or not, if it's worth adding to your program toolbox or not. So let's talk about Grasshopper. What is it designed to do? What did the engineers of Grasshopper try to give users the power to do? We already know what makes Rhino Rhino, and Grasshopper is a plugin inside Rhino. So they're very much like sisters. They very much go together. And we know that what makes Rhino special is that it's a 3D modeling program, but it gives you these 4 views, right? Architects love working in orthogonal ways, and by giving you 4 views at the same time, that helps you see what it would look like in plan and in section. That's fantastic. That's what makes Rhino special compared to other 3D modeling programs. But what happens when you introduce Grasshopper? Well, Grasshopper is a plugin inside of Rhino, so all of these items, all these objects, can be edited or modified or drawn. You can draw them from scratch, just like you can draw a new box in Rhino. You can edit or modify these objects in Grasshopper in a parametric way. Okay, what is it? What does parametrics mean? Parametrics are the key word when we're talking about Grasshopper. Grasshopper and parametrics are like synonyms. So whenever we make changes in Rhino, we create new objects, we type in a command. Let's get rid of my placeholder stuff here. Let's say that we want to make some changes to this box. Here is my box, okay? You know how Rhino works. You say in the command line, copy, enter, okay? Copy from where to where? Copy from here to here. There we go. Oh, one more here. Enter. Done. The command is complete. I have now made my change. I have now done my command and executed it. And it's not just copy. We've also got scale. There we go. Scale from where? Scale from here to here. Aha. There we go. I've done the command. I hit enter, and now the command is complete. You know how this works. You know how Rhino works. But what happens if I want to start making changes parametrically? Okay, we're going to start talking about what does parametrically mean. So let's look at some examples of real architecture in the real world, and we're going to start to understand what parametrics are. So here is an example of a real building in Chicago. This is called the Aqua Tower. And the reason I'm showing you this one first is because this is a real construction. Okay, parametric design tends to be really wild and crazy, and usually it never gets built because it's too wild and crazy. But if you find a good architect and a good engineer and a good construction builder who can put all these things together, parametrics can exist in the real world. And when it does, it's very special and pretty rare. So so using Grasshopper, write this down. This is why is Grasshopper special? Point number 1. We're using Grasshopper to try to create something really advanced. We're trying to show that we're on the cutting edge of architecture and engineering coming together to show something really advanced and really spectacular to the eye, just like this building. So what are we looking at? Every single floor cantilevers and waves and gives you a different shaped balcony, but they're not all exactly the same. Every floor above the one below it is a slightly different ripple. And when you do that across 40, 50 floors or whatever it is, you find this result where it looks like the whole thing is waving, or like the whole thing is water or something. That's why it's called the Aqua Tower. And we know that the architect, her name is Jeannie Gang, we know that when she designed this, she didn't just come up with a really cool sculptural wave and then build it. We know that she designed each one of these waves, each one of these openings in the facade, each one of these ripples to respond to something. She wanted to make sure that every balcony was a certain square foot at least. We know that every opening was receptive to where the sunlight was falling. We know that every balcony had to receive a certain amount of thermal mass. So everything was calculated. I'm telling you that she calculated every single ripple, every single floor, and this isn't just some sculptural blob just for the fun of it. But in order for her to create a mathematic formula that generates each one of these curves and gives her the ability to push and pull each curve, each point, it required use of a very advanced program. That's Grasshopper. Okay, so let's talk about some other examples in the real world. Here we go. Here is another very famous building, and it's the same concept. At first glance, or at someone who doesn't know anything about math or architecture, they would just see this crazy round glob and say, whoa, I've never seen a building that was a glob. Usually all buildings are a square with a roof. But in order for her to create this glob, she had to design exactly where the low point would be, exactly where the high point would be. And when she decided, yes, this is the part that should be open because it receives the most sun. Yes, this is the part that should dip because that's closer towards this other building, or whatever it is, whatever her parameters were. She then decided that she would create a formula where she could push and pull each of these elements of the roof that would morph into the wall, that she would raise them X high above the ground, and she pushed and pulled them into the final position that made the most sense, and then she said execute. And because it was done with a computer, she was able to find every single point on her shape and turn it into an architectural drawing. And it was able to really be built in the real world. That's fascinating. That's very advanced. So let's just take a look at some last little, this is what parametrics looks like. At first glance, it just seems like it's crazy art. But at second glance, you say, oh my gosh, this is mathematic. This is an amazing example. It's a bunch of lines that repeat, and let's look at this point on the line here is kind of in the middle. This point on this line is kind of higher up. This point on this line is a little lower down, and then even lower down to over here. And we have chosen all those points and said, raise them up, create a ridge, and all of the lines correspond. And it gets really complicated because over here we say actually take this point and dip back at this point over here, dip back, and we can move those points wherever we want on the lines and create a very different valley ridge final shape. But it's all calculatable, it's all executable, and that's what makes parametrics a lot more mathematic than just regular art. Same thing here, it's a surface, but we divide the surface into a grid, and we say take every grid square and make it a little bevelly suction cup. Take every point in the middle and suck it back. Take this point over here and bring it forward. And we're now able to build this thing because we know we can measure the height differences between all of our little grids. So it's very advanced, and I hope that if you start going around and looking at architecture in the real world, you'll notice when something is parametric or not. And be prepared for it to be rare. Be prepared for you to not see it that often because, again, this takes a talented architectural design with an engineer who's willing to do it and a construction builder who's willing to do it for you to even see it in the real world. So let's now move from, okay, I've identified what is parametric design into using Grasshopper. So let's go over here and let's start from scratch. And I'm just going to remind you again how Rhino works, because we're going to move from Rhino's workflow into Grasshopper's workflow. They're very different. So let's say that we have got Rhino and we've got a cube. And I just showed you this, you know that this is how we've got a cube, and if we want to make changes to it, we make the change and then we say we're done. And then we make another change and we say we're done. Make the change and then we're done. So this is how you make changes in Rhino. Let's now open Grasshopper and start making some of the same changes, and let's see how that works. So we're going to go to our button here, is provided in the standard tab. This is it right here. Or we can use the command and we can say Grasshopper, enter. There we go. And she's going to load. We get our cute little splash screen that tells you the date. And look what happens. A new window opens up. Get started and go away. And this little window is inside of Rhino, okay? If I close Rhino, Grasshopper will close too. If I close, there we go, the whole thing closed. If I close Grasshopper only, Rhino will stay open, okay? So here we go. I'm going to reopen my file, and we're going to open our Grasshopper. And this little window floats around inside. Good to have two computer screens for this. If I close it, Rhino stays open. And I open it again, and it's the same thing. So let's now start looking at changes happening in Grasshopper versus changes happening in Rhino. Ordinarily, I would do this on two screens, but we're going to show it like this. So let's start with a box right here. Boop, boop. There we go. Now, inside of Grasshopper, instead of making the change and then hitting execute, we're going to log the change on a graph. We're going to log it on a sheet of scratch paper. We're going to write it down, and we're not going to erase it. So let's say that we want to make a copy of, let's say that we want to scale this box. Okay, we're going to get to copy in a second. Let's say that we want to scale this box just like we did in Rhino. We're going to go to Grasshopper, and we're going to double click, which means new item. And we're going to type in scale, and it gives me a whole bunch of options for what kind of scale. All these different options of scale. This is the one I want, I know that. This is basic generic scale. And look at this, it creates a node. This is a node that can be dragged around and plopped wherever I want. It's all free. It's all just a free open map. And this node is scaling, but it's asking me to give it a little bit of information to say, scale what object? Scale it how much? Just like we have to type those in Rhino. We have to punch that into the command line. So I want to scale this box, okay? So I'm going to use another node here in Grasshopper, another node, and this node is going to be a container for an object inside of Rhino, okay? They're linked into each other, right? So let's create a container. A container for what? A container for geometry. They have containers for different kinds of objects in Rhino. This is just a generic geometry, any closed shape, right? So look at this, it's orange, there's an error. It's saying we don't know what data you're talking about. So when we right click on our node and we choose what the geometry is, Grasshopper goes away and says, you're in selector mode right now. Go inside Rhino and tell us which object you want to be in the container. Here's my cube, I click on it, boop, and it turns green. And now my my node is not erroring anymore. It's not orange anymore. So I can also double click, or excuse me, I can just click on my node and it'll show me inside of Rhino which object I'm talking about. Very handy. So watch what happens next. I'm going to use this container and I'm going to connect it to this node here using a little arrow. I want to put this geometry into here, into this input of my geometry node. These are the inputs on the left. These are the outputs on the right. So I have now told it, this is the geometry I want. It knows, but I've also got some more inputs that are not filled in yet. Where am I scaling it from? How much am I scaling it to? When I hover over the little input, it tells me what it's asking for. So I need to tell it what point to scale from. Well, let's just do the center, right? 0, 0. That's where I want to scale from. So I'm gonna use another node, and this is gonna be a container for a point. Okay? Just like there's a container for geometry, there's a container for points. And I'm gonna put a point inside of Rhino here. I'm gonna put a point at 0, 0, 0. Boom, there we go. Can you see it? It's right there. That's my point. Okay, and I'm going to put that point in this point container. Okay, and you can probably guess what I'm going to do after that. I'm going to take a right click on this node, and I'm going to say select which point. Which one? This point right here. Boom, and it turns green. You can see it. It turned green right there, and I'm going to now drag this node and say, this is the point that I want to scale from. Click. And now, last but not least, I'm going to determine how much do I want to scale it. And let's say I want to scale it 3 times. I'm going to use a new node. So I double click and I say, what is my new node? And my new node is going to be a number node. Okay, so let's just use a number node. When I type in the number that I want, it gives me a number node like this. And it's set to 3. Here we go. We're going to go. Boom. Whoa, it just scaled it 3 times. Look at that. Now this is complete. All 3 inputs are filled in, and this is complete. The action has now been executed. And it's giving me a ghost of my new scaled box. The box it's red. Everything that you, I guess this could be any layer. This could be any layer. There we go. But it gives you a ghost in red of your proposed change. Now, this is just a ghost, okay? When I click on it, it shows it in green to help me find it. That's very helpful, especially when we get down the line and we have lots of objects on here. But this is not real, okay? This is just what you would do if you made these changes. This is real, but this is not real. The ghost is not editable except for in Grasshopper. So let's look a little bit more closely at what this ghost means. So when I put in my number node, number nodes are this fun feature where they're in the form of sliders. This 3 is automatically provided with a slider where I can scale it to be 2 or 8. And look what's happening. I can live scale the thing and see it at different sizes. Ooh, this is starting to get grasshoppery. Okay, so when I say let's go on to another command, let's do a little bit more to the box. Let's not just scale it, but let's also rotate it. Okay, let's get in a rotate command. Let's do rotate, and look at, there's so many rotate options. We're going to discuss why there's so many options later. Here we go. Similar, it's asking for what is the geometry that is going to be rotated, and what are we going to how much are we going to rotate it, what angle are we going to rotate it, and rotate where from, right? You know that you have to input all these things when you rotate in Rhino. So let's there we go. Oh, and look, it has already started to show me the rotation. But of course, I want to be in control of what it's going to rotate. So I'm going to punch in a number. And let's say I want to rotate it, I don't know, 30 degrees. There we go. I put in my number node. And I want to rotate it 30 degrees. And it's also saying, where do you want to rotate from? And I liked rotating it along 0, 0. I think that's what I want to do. So I'm going to take this node. And I'm going to copy, Control-C. Paste, Control V. There we go. I now have another node that's the container holding the same point. Both of these are holding that same point that's inside of Rhino. So let's bring this over here and let's go. Aha. looks like it was already by default at 0, 0. That's handy. So watch what happens when I rotate my box. Whoa, I'm rotating it all these degrees. So that's very interesting. Now, you'll wonder, why is it showing me this scale box and this rotator and this? Like, it's getting confusing. It's all this clutter on here. And you're right. It shows you every single step of the process. And imagine what's going to happen when we start adding all these nodes and making all these changes to our box. We're going to have so much to see. And we only really want to see the last action. That's all we really care about. So we're going to have to, as we work, we're going to have to hide earlier nodes. Hide it. Hide it. There we go. And we're only now seeing our last guy here. Nice. So let's keep going. Let's do one more, just so that we get the final feeling for using nodes. So let's do one more. So we've said we've scaled it, we rotated it. Let's make an array. You're familiar with the array command in Rhino, right? So let's say array. Here we go, array. And it looks like there's so many options. Let's just do a simple one. Let's just do a linear array. And look at this. The inputs, it's asking us for, what is the geometry? Aha, this geometry right here. Boop. Whoa, look at that. It already started to array it for me. But of course, that's not what I want. Be prepared for you to be working in Grasshopper and then you say, that is not what I intended. And then you got to troubleshoot. So we're definitely going to have to troubleshoot now. I'm seeing that this array command this array node is asking me for which direction do I want to array them? X, Y, Z, or some other direction? And how many items? How many items? So let's go and let's put these numbers in. How many items? Let's say, I don't know, 8. 8. How about that? And let's go. Aha, 8 items. Okay. And look, we can have more or less. And let's also say what direction. Well, it looks like it's automatically defaulted to go in the X direction. So let's put this in the Y direction. Let's say Y direction. There's a node just for the Y direction like this. And notice how when I put in a Y direction node, it has an input. So I can actually say how much in the Y direction, right? These items are spaced apart. So I need to say how much are they spaced apart in the Y direction. This is how many items in the total array, but this is going to be how many items, how much is the space apart from each item. So let's get ourselves a new number node, right? And let's say, I don't know, space, 20 feet apart. How about that? Let's just try it and see. Connect, and then connect. Oh, look at that. It sent them in the Y direction, and that, sure enough, is 20 feet apart. Well, let's troubleshoot again. Like we said, this is clearly not what I want. It looks like the box is so big that 20 feet barely shows you any spacing. So let's do way more spacing. Nice. But you know what? They're still so big. I really don't like that. So let's just scale our box down. This is the scale node, and we're going to say, I'm going to edit the number node so that I can actually control it down to the decimal. So obviously, if I go all the way to 0, well, I'm scaling it times 0, so error, it doesn't work. You just deleted the thing. But if I come up a little bit, there we go. That's what I wanted. I wanted a nice little small box that I could adjust the spacing of it and really see what's happening. So I have 6, but I could have way more, or I could change the spacing. Ah, that's amazing. And remember, the whole thing is rotated, so I can rotate these cubes. Very interesting. So at any point, I can make changes to all of my, I can make changes to my changes because they're all tracked here and they're all logged here and they're all displayed in a linear left to right fashion. So let's now go from, you understand how Grasshopper works, you understand how it uses these nodes and these noodles to make changes. Now we're going to create something that is very parametric and that maybe you can use in a future project, just sort of like a template. So I'm going to delete all of this, delete, and we're going to start from scratch here. I'm even going to delete this, and I'm even going to delete this. Here we go. We're really starting from complete scratch here. This is an empty document. So let's say this is going to be a sample arrangement of something very simple that you can build in Grasshopper. Let's take a line and let's just draw ourselves a line inside Rhino like that. Okay. Now let's take another line and we're going to make this one a little bit more fun. Interesting. Okay. Now we have 2 lines inside of Rhino. Just like we did earlier, we referenced objects inside of Rhino to use in Grasshopper. So let's create a node for a container, and this is going to be a container for a curve. A curve. There we go. Let's zoom in on it here. There we go. Look at that. It's empty. It's saying which curve. Just like we had a point, we had a geometry, we have curve. There's many. There's many that we could use here. Mesh. So let's say we want to select a curve to be in that container. We want this first one. It highlights it green. And if I click off of the node and onto the node, I can see which one is highlighted green. So we're going to need to do this again. So we're going to create a new node and we're going to say curve. And this one is going to hold our other curve, okay? Right click and say set one curve. Set which one? This one right here. Boom. And it got it. Now we can see which one is which. This is great. So that's fantastic. Okay, so now we're going to use one of my favorite nodes ever. This is called the divide curve node. Divide curve. I love this one. Okay, we're going to choose a number of points to divide the curve up, and let's just see what happens when we drag this into here. Whoa, look at that. Whoops, look at that. It divided my curve into several points, and it looks like the default is this number of points. But of course, I'm in control, so I'm going to choose how many points I want there to be. So I'm going to get a new number node, and I'm going to say, let's make it 20, 25, 25, 25, 25. And let's see what happens when we drag this into the count. Yeah, that seems like a little bit too much. But it's okay. I can do like this. Much better. I'm dividing how many points. And now, let's look at what the output is for the divide curve node. The output is points. When I hover over it, it's telling me we've given you 8 points, 8 locally defined values, 8 points. Now you're probably wondering, wait, I set it to 7. Why are there 8 points? And this is a math pro tip for you. The 0 point is one of them. So it's actually 0, 1, 2, 3, 4, 5, 6, 7. That's 8 items. And that'll be useful when you're starting to look at, long lists of items inside of these nodes. So remember that even though you set it to 7, there's actually 8 items, and you'll see that when you use the output of these points here. So let's now divide the curve again on our other curve. So let's do a divide curve, and let's bring this guy into here, and again, it set it as a default, but I want to control the number, and I want there to be way more on this one. I want 25 on this one, and let's go aha! And just like the other, we can set how many points on the curve we want. So this is where this gets really interesting. Let's say I want to connect points from this line to points on this line, and we can do that using a node called create a line. And when I create a new node and I say line, notice that there's like all these different notice that there's all these different line items. Fit, like there's like so many options. This is the one I want. I know that because I've used this program. It's very simple. What's the start point? What's the end point? That's it. But of course, you're gonna see Grasshopper gives you tons of advanced options. So watch what's going to happen when I use this node here. It's asking me to input something. I've got 8 points here, and I've got 19 points here. If this is the same number of points as both items, and I give it a start point and an end point, it will just automatically know as a computer that it wants me to put point 1 to point 1, point 2 to point 2, 3 to 3, 4 to 4, 5 to 5, and it'll be perfect. But since these are different numbers, look what happens. It gives me this weird error where once I get to the shorter number of points on the left here, it just starts to connect all the rest of these guys to that last point, which is obviously that's like a glitch. That's not what I want. But let's see what happens when I set this number to take the place. Oh, now I'm putting the same number of divisions on both curves. Aha, that's definitely what I want. Now, this is not the worst glitch in the world, but it's definitely not what I want. So let's stick to our same number of divisions for now. And you now have an idea of what may be causing an error if you ever run into errors in the future and you need to troubleshoot. Keep in mind that the computer automatically put a list of points and a list of points into the input rather than just a single point or a single point. It can handle a whole list of points. And as long as the two lists match each other, we can create several lines at once. And look at the output. The output is 19 lines, right? The output is now 43 lines, right? Aha, very interesting. Okay, so let's now take this to the next level. If I edit my lines inside Rhino, everything stays connected. Whoa. Whoa. Right? And wait a minute, this is about to get really good. Oh. Oh, this is so good. Oh my gosh. That almost looks a little bit like this, wouldn't you say? Interesting. Well, we have the ability to edit this curve however we want, and we can create all sorts of funny results. And you start to see how maybe this is a roof structure. Maybe this is a wall structure. Maybe this is a fancy facade. Maybe this is a something that you can walk underneath. I don't know. Start to get creative, right? And let's now do one more change inside of Grasshopper before I let you run with it. Let's say we want to use the pipe command, the pipe node. This is going to say, I create the pipe node and I'm going to look at what is it asking me for. Well, it wants to know which line, which curve are you putting a pipe around? What's the radius of the pipe? And a yes or no input for do you want to cap the ends. That's cute. So let's say that we want to bring in our several lines. And look at that. It has made pipes around each of the curves. You see that? And they're definitely way too fat. They're hitting each other. So I can either, what can I do? I can either have less, or I can make it a smaller radius. So let's go in here and create a number node, and let's have a really small radius. Let's just have a radius of 3. Okay. Well, I thought that 3 was small. It turns out 3 is big. So let's make it 2 or 1. And let's also set the, I did this earlier, let's also set the settings of the number node. I double clicked on it. And I want to be able to change the numbers, not just 1, 2, 3, but actually by decimal. So I can actually go really small, have full control, and have these thin little sticks, okay? And I'm able to bring them, to have more of them now since they're so close together. Now, I want you to think like an architect. These sticks could represent steel beams. It could represent actual timber sticks if you're building something like this in the woods. It could represent wooden logs, right? It could be any item, but all I'm showing you is the geometry, and I'm showing you that this geometry is calculatable. I can measure with measure tools exactly where each one falls, exactly which XYZ point each of these points are, and we can go build this thing. We can go build this big, beautiful alien thing. Isn't that fascinating? So here we go. We've got our pipes, and we've got our fancy shape here, and we've got the ability to edit it however we need. Whoa, all these crazy results, right? Now, this is a very simple script. A script is our word for a Grasshopper file. It's like a file. It's like, we call this the script. Very high-tech engineering terminology here. We call this the script. And this script is very simple. Look, it's only a couple nodes, and you may see in advanced Grasshopper files, you may see tons of nodes and spaghetti strings all over the place, and creating some really wild whole buildings and stuff. And by comparison, this is a very simple one. But here's what I want you to think about. When you decide to use Grasshopper on your project, you have to make sure that you're using it in a smart way and in an efficient way, because Grasshopper is not Rhino, okay? You don't want to start building stuff in Grasshopper. You build stuff in Rhino. You build your objects, you build your final building in Rhino. But Grasshopper is just about building logic. It's just about building the arrangement of lines and lines between lines and the skeleton that objects are going to sit on, okay? So your object that you come up with, which is a beam or a fancy column or a special component piece, you're just applying that component piece to the skeleton that you made in Grasshopper. And look at how simple this script is, and yet we have a very beautiful result. That's kind of the key takeaway I want you to realize. You can get a very, very powerful momentum, a powerful and impactful gesture with just a very simple script. All you got to do is start with a line, divide points on the line. Kind of looks like this, don't you think? Divide the points on the line, and then make little changes, make little tweaks, and start to create something that really flows. And this flow can be in response to the ways people move, where the sun is coming in, right? You can say that this is responsive. It's not just organic and artistic and sculptural and random. So bear in mind, as you make stuff in Grasshopper, you don't need to get crazy. You'll see tutorials on Grasshopper to build all sorts of wacky stuff and like big, massive projects with all these like teeny tiny little features and edits. That's amazing, and that's advanced Grasshopper. But for a beginner, you don't even need to know that much, and you can still start to create something that has a big impact, and your brain wasn't breaking because you were trying to figure out how to build it. And I think the last thing I want to add is, how do we apply this to a real project, right? I encourage you to take this, what I've shown you, and run with it and maybe implement it into a project. And don't necessarily force it into your project, because I promise you, when someone sees this on your board, when someone sees this on your board, they're going to know that it was made with Grasshopper instantly. People just know. They're like, whoa, that is parametric design. Look at that. I can just see it. And when you do that, you have to be able to explain, why did I do that? Are you just flexing? Are you just showing off? No. These lines represent a wave of motion that the people move. This is designed to accept heat at certain times of the year, right? It's all about design. So I encourage you to think about, what application could this crazy skeleton thingy be used for? The answer is probably a facade, probably a roof, or probably a... that's all that comes to mind right now. Maybe the shell, like in this case right here. But keep your eyes open for facades, like this, facades, shells, or roof structures. Okay, that's typically where you're going to see a most reasonable way to apply some crazy design like this in a real architectural building. Okay, so I'm going to let you run with it. So, and of course, don't forget that you can find Grasshopper tutorials online, and the more advanced you get, the more practice it's going to require. But but you don't have to become advanced right away to make something amazing. You don't have to learn all these advanced Grasshopper techniques, and it's going to be tricky. It's going to be like a whole new frontier using these nodes and these noodles instead of Rhino, but that's okay. It's going to take a long time to learn and to feel comfortable in it. You know that that's the case for any program, but with just diving in like 2 weeks or less, you can already be making stuff like this. So Write down Grasshopper on your list of projects to learn, your list of projects to try out, and please try to implement a Grasshopper element into your project just so that you can say, hey guys, look, I'm trying to be on the cutting edge. I'm trying to work with parametric design. I have the ability to do it, and aren't you impressed? Okay, so that's it. So I'm going to call it right here. So let me know what you make in Grasshopper, okay? One last thing that I left out, I want to touch back on this. Remember that all of these items that Grasshopper has created are ghosts, okay? They're not real. They're not really here inside of Rhino. The lines are here. We made those in Rhino, but these items are ghosts, and they will be ghosts as long as they're in Grasshopper edit mode and able to be changed and rotated and stuff like that. So I want to work in Grasshopper with all of these items being these ghosts, and I want to work it and get my position right and get it to be how I like it and make all these edits and make all these iterations and changes. And then when I'm finally done, when I'm finally ready for the end of the product, I want to say, okay, it is done. So now export, right? Export these items. And the word that Grasshopper uses for export is bake, like bake a cake. So I've decided, let's make it exactly the way I want. This is good. Perfect. That's how I like it. I want to now bake this. So I'm going to go to any node you can bake at any point. So I'm going to go to my last one, and I'm going to right click on it, and I'm going to say bake. And it's actually going to say, these are some settings. How do you want to bake it? I'll say, yeah, okay. And look at that. They have now turned into Rhino objects. Oh, and now I can render it. Now I can cut a section of it. Right now I can group it. And actually, it's a little confusing that it put them all on a red layer. But indeed, that's how this works. And actually, the ghosts are still there. Like, the ghosts are still showing, right? I just deleted those. But I want you to understand that everything that happens in Grasshopper is not real. It's just this ghost, what would happen if you made these changes. And then at the very, 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 very end, we bake, okay?